All right, guys, in this second part of this hypothesis series video, we're going to be looking on how we can find the critical region of a two-tailed test. So two-tailed test is where the alternative hypothesis is not equal to zero. So let's have a look at this question here. A random variable x has a binomial distribution n equal to 40 and p. A single observation is used to test h naught where p is equal to 0.25, and the alternative hypothesis where p is not equal to 0.25. So let's use a bell shape to represent and visualize this question a lot better. So this is stuff they're going to be learning later on, but again, it helps with visualizing it. So when you're finding the critical region, we're finding the extreme values. Okay, so critical value here and critical value here. And using this critical value here, we need to find these regions here where we find the extreme values. So here it says using 2% level significance, find the critical region of this for this test. The probability in each tail should be as close as 0.01. So we are saying that we are splitting the significant level and we're trying to find the critical region of the 0.01 top and the bottom of 0.01%. So the bottom 1% and the top 1%, because we took that significant level and we split into two parts here. As always, what we assume in order to do part A, we assume that H naught is true. Because H naught is what we believe and it is true and what we have accepted. The alternative hypothesis is a new argument someone is bringing that we want to check. We want to verify whether the argument is true or false. And we do this by finding the critical region and calculating the extreme values. So in this case, we assume the H naught is true. And if H naught is true, then what does that mean? That X is binomially distributed where n is equal to 40 and our P is equal to 0.25. So by doing this, we need to test and trial to find the critical region for the bottom part where we get the probability as close. Remember in the one-tail test, we said we need to find the first value that goes below the 0.05% in that case was. But when it's two-tail test, we don't care to find the first value that is less than that, but we care about finding the value that is close to the 0.01%. Okay, sorry, the close to 0.01, which is also 1%. So in this case, for the bottom part, what we can do, so for the bottom part, we can try test and trial finding x is less than or equal to 4. And if we try to do with less than or equal to 4, and n is 40 and p is 0.25, then that gives us a value of 0.0160. And if we repeat the same process for the other value, where x is less than or equal to 3, therefore that gives us a value of 0.0047. So we need to see these two values are very close. So this value 0.0160 goes above the 0.016, and we have the 0.0547. Which one of these value is the closest to the 0.01? And you can use a calculator to check it, but we can clearly see that when x is less than or equal to 3 is equal to 0.047, this value here is the closest to 0.01 compared to the 2, because 0.01 sits in between these two values here. So we know that this is going to be critical region for the lower tail. So now we need to replicate it and find the same exact thing for the upper tail. So for the upper tail, in this case here, upper tail, let's have a look at that. So for the upper tail, what we're doing here, we're finding the probability that we have the top value. So it has to be x is greater than 19, greater than or equal to 19. So if you do that, then that essentially means you have to do 1 minus probability that x is less than or equal to 18. So therefore that gives us 1 minus 0.9983, which gives us a value of 0.0017. So we can see this is close enough to the 0.01, but let's see if we can find a number that's even closer. So let's do probability that x is greater than or equal to 20 or 18 in this case here, sorry, because we can try to see if it's a number that's below that is closer. So that gives us 1 minus probability x is less than or equal to 17. So if you put this in a calculator, that becomes 1 minus x is 17 and it's 40, p is 0.25. That gives us 0.9884, and therefore that gives a value of 0.0116. And we can see that between the two values here, which value is closer to the 0.01. And in this case here, we can see that this part here, when x is greater than or equal to 18, that gives us the value that is closest to the 0.01 for the top part in this case here. Therefore, we find our critical values. Once we find our critical values, then what we need to find is that we need to specify our critical region. So our critical region are as follow. For the lower tail is going to be x is less than or equal to 3 and greater than or equal to the bottom number possible, which in this case is 0. So for the lower tail, this is our critical region. And for our upper tail is x has to be what? Greater than or equal to 18. But what is the maximum it can go up to? It can go up to all the way to 40. And this is our critical region for the upper tail. So hopefully this is clear. We find the critical regions by finding the number for two-tail test only, by finding the number that is closest to our significant level, which is 0.01. And remember, one of the very common mistakes is people not splitting the significant level. If the significant level is 2, then we are making sure that we are splitting that for the upper tail and the lower tail and finding the value that's closest to 0.01. And then, to conclude this question here, for part B, what do we need to do for part B? So part B is telling us to write down our actual significant level. So actual significant level is the probability that we use for our critical region. So in this case, that would be 0.047 and 0.0116. So actual significant level in this case here will be 0.0047 plus 0.016116 in this case here, and therefore that adds up to 0.0163, which is equivalent to 1.63%, which we can see that is very, very close to the actual. Maybe you're not going to see this because of the icon. Let me write up here is 1.63%. So we can see that this is very close to the 2% significant level, but this is the actual significant level in this case here. Okay, so hopefully this is clear. This is how you answer a question where you find the critical region of a two-tailed test question. Any question, let me know down below in the comments.